Basics of Concrete by Grant Clausebart. Cement and concrete. Cement is a fine, soft, powdery type substance. It is made from a mixture of elements that are found in natural materials such as limestone, clay, sand, or shale. When cement is mixed with water, it combines sand and gravel into a hard, solid mass called concrete. Cement and concrete aggregates. Fly ash, the most commonly used pozzolan in concrete, is a byproduct of thermal power generating stations. Slag cement, formerly referred to as ground granulate blast furnace slag, the glassy granular material formed when molten iron blast furnace slag is rapidly chilled. Silica fume, also called condensed silica fume or microsilica, is a finely divided residue resulting from a production of elemental silicon or ferrosilicon alloys that is carried from the furnace by the exhaust gases. Cement and concrete admixtures. Admixtures are a natural or manufactured chemical which are added to the concrete before or during mixing. The most often used admixtures are air entraining agents, water reducers, water reducing retarders, accelerators, superplasticizers, and corrosion inhibiting admixtures. Water reducing admixtures usually reduce water content for concrete mixed by 5 to 10%. Retarding admixtures slow the setting rate of concrete. Accelerating admixtures increase the rate of early strength development. Superplasticizers reduce water to about 12 to 30%. Corrosional inhibitors admixtures used to slow corrosion of reinforcing concrete. Making and placing concrete. The ratio for mix of concrete is 1 to 2. Handling and placing. The contractor has many different ways to transport and pour concrete. You can either do it by buggy, truck, pump truck, or sometimes you can do it using conveyor. Curing concrete. Curing takes place immediately after concrete placing and finishing, and involves maintenance of desired moistures, temperature conditions, both at depth and near the surface, for extended periods of time. Formwork. Formwork is either temporary or permanent molds into which concrete is poured. Reinforcing. Concept. Concrete in which metal is embedded so that the two materials act together in resisting forces. We use reinforcing such as bars because concrete has no useful strength. Put reinforcing steel where there is tensile forces. Steel bars, rebar. Reinforcing bar or rebar is a common steel bar that is hot rolled and is used widely in the construction industry, especially for concrete reinforcement. They put ribs in rebar for better bonding to the concrete. Fabrication and erection. The fabrication of reinforcing steel for a concrete construction project of analogous to the fabrication of steel shapes for steel frame building. We use wire and welds on rebar to hold the rebar from shifting before until concrete is poured. Reinforcing continued. Reinforcing a simple beam. The bars in the concrete are held by bond forces. They need to hold each other in place by compression or bends in the rebar. The length of the rebar increases the tensile strength and supports the beam. Reinforcing structural slabs. One-way slabs must be provided with shrinkage temperature steel, a set of small diameter reinforcing bars set at right angles to, and on top of the primary reinforcing in the slab. Their function is to prevent cracks in the slab. Two-way slab action. They share the bending forces equally between the two directions on the slab. They are shallower and use less reinforcement, allowing you to save money. Reinforcing continued. Reinforcing columns contains two types of reinforcing. Vertical bars. They share compressive loads, resist tensile stresses, and impart ductility to the column. Ties in smaller bars ties around vertical bars and helps prevent them from buckling. Column spirals. They are wired around vertical bars like foursquare. Column ties are closely spaced hoops individually wired in space. Fibrous reinforcing. Fibrous reinforcing fibers of glass, steel, and propylene to concrete mix. Plastic shrinkage cracking frequently occurs while concrete is in the plastic state. Macrofiber reinforcing protects against the plastic shrinking and resists long-term cracking. Concrete creep. Concrete creep is the deformation of the structure under sustained load. Pre-stressing. Pretensioning is used with precast concrete members. They stretch the metal supports in the concrete beam to keep the beam more strength for less bending. Post-tensioning. This occurs mostly on the site. They bend the metal rods in the opposite direction of the tensile strength so that the forces any strain to greatly be reduced. And now for my section, I did section gray. Joining precast elements. Elements in joining precast are slabs, beams, girders, columns, and wall panels. These are all combined together to make a very sturdy precast frame for the building. Construction process. Before any building can begin, it is drawn up and reviewed by the engineer and the architect. Then any molds that are needed are made following up with the precast components. Precast concrete and building codes. The fire resistance rating are determined in hours and have two types, type 1 and type 2 construction. Uniqueness of precast concrete. Precast is crisp, slender in relation to span, precise, repetitive, and highly finished. They are all weather erection of structural steel framing with self-fireproofing. And then my reference page, I got most of my stuff from the book and online sources such as Portland Cement Association and Reinforcement Rebar in Ohio.